All right, so why am I here? Artificial intelligence as a technology is changing the world of work. And organization development, you professionals who are engaged in OD, human resources, learning development, have a very important role to play in this transition. And so what I want to do is share some of my perspectives on artificial intelligence as a technology so that you can consider how to use your own tools and experience to help organizations and employees address this important change. So in this session, we're going to have basically two parts. The first part is I'm going to talk about artificial intelligence, what it is as a technology, what can it do, and how it is impacting the world of work. The second part, we're going to address, well, what does this mean for organizations, employees, and professionals who seek to help those people? So in the second part, we're going to be doing breakout sessions, and it's going to be an open discussion that I'll fuel with a few bits of information, but primarily you are the professionals, you are the ones who are going to be considering these things. And my goal is to tell you enough about artificial intelligence so that you can apply your experience and tools. Warning, my background is in engineering. Many of you know me from from ODN. As Mary mentioned, I've been on the board, I've been with Community Consulting Project. However, most of my background is in engineering. And as a consequence, I'm prone to things like being fascinated with technical details, prone to things like death by PowerPoint, that sort of thing. And I've really tried to suppress those tendencies in favor of what I hope will be an illuminating discussion. However, I can't resist taking you down a little deeper than perhaps you've gone before in these technologies, because I'm really eager to share with you some of the fascinating things that are going on in this area. And in order to really get that, we're going to have to dive a little deeper than perhaps you expect. So bear with me there. And also, I'm very happy to entertain questions, and we'll be looking for feedback throughout to help me sort of gauge where I need to clarify, where I need to go. So I'm looking forward to this very much, and let's get started. First of all,
I'm also seeing a question of how to manage a bot employee team, Tom.
Okay, yeah, I saw that. All right, as I mentioned, first I'm going to talk about AI. Artificial intelligence is actually all around us today, as probably many of you know. Personal assistants such as Siri use artificial intelligence to understand what we're saying and to be able to respond to it. Google Translate, you know, who would have thought at this point we can so readily translate pretty well between languages. Self-driving cars. There are very few examples of cars that truly drive themselves, but many cars today have advanced AI-driven systems that can be enabled to allow you to keep a safe following distance from a car, to stay within lanes, to automatically brake when a pedestrian is in the way, that sort of thing. This is all AI. AI has been in the news. This is quite a while ago when Watson, an AI developed by IBM, beat some of the champion Jeopardy players. Really an interesting achievement given the breadth of knowledge that needs to come to bear on that. And you may have seen in the news that one of the oldest board games, Go, some of you may have played Go. It's distinctive and it's a game originated in Asia. And for centuries, there have been people who devote their lives to becoming Go masters. It's a game of fairly simple rules, white stones and black stones, where you try to surround each other and take territory. However, there are so many possible rules that it takes very long time for human beings to master this. And a few years ago, an AI was developed using some technologies I'm going to talk about in more depth that was able to beat the world champion Go player. It didn't win every game, but it bested, won more games in the series. This particular version, this particular AI that was beat the Go champion was trained on records of human games and looked at thousands of games in order to develop strategies that were successfully used against this human. But what I find even more fascinating than that was that a second version of this AI was developed called AlphaGo Zero that was not shown any human moves at all. It was only shown the rules of the game and was able therefore to play and determine whether it won or lost the game. So they took this AlphaGo Zero, this sort of blank slate, and had it play against AlphaGo, the original AI Go player that had beat the human champion. They played 1 million games. And this AlphaGo Zero developed to the point where it could beat the superhuman original AlphaGo every game. And human players watching the moves that were made by AlphaGo Zero, it was like watching an alien play. They saw moves that are now being used to train human Go players that they just never imagined. So pretty amazing stuff. AI is used in drones. You know, you've probably all heard about Amazon's experiments to try to deliver goods to us through drones. It's already being used extensively for delivering medical supplies in hard to reach places and so forth. And it's also being used, and this gets a little toward the question David raised, to purposes that can be somewhat nefarious. One of the things that can be used is to create fake pictures, fake videos. You may have heard about some of these issues where you can create a videotape of, let's say, Barack Obama, a famous figure, and you can, in effect, put words in his mouth that he never spoke, and it looks very realistic. This particular example that I'm showing here, it's across, there are pictures of 2 real people on the top, source, and then there's a picture under destination. Let's see if my pointer shows up here, of someone else who's a real person. And then these 2 people that are in the lower right are, an AI has created a composite identity between the person above, this guy, plus this real woman, and it's a fictitious person. Similarly here, they're able to, through facial recognition, the AI develops the patterns of appearance that they can then be used to generate fake people. Okay, so one of the questions I often hear is, what is AI exactly? It can be confusing. artificial intelligence, generally speaking, refers to technologies that enable machine systems to perform tasks that are normally associated with human intelligence, like recognizing faces, like understanding language, that sort of thing. Sometimes we use AI in another sense, and we talk about an AI as an entity, because one of the goals of AI is to develop entities. For example, it might be a chat bot that has a degree of autonomy and existence you might think of as an individual. So artificial intelligence is that broadly. But I want to go a little bit lower, a little deeper than that, to talk about 4 different kinds of technologies that underlie artificial intelligence and are used today. One of the earliest versions of AI was called artificial neural networks. And some of the early work, I believe it started in the 40s, was based on observations of the human brain and other biological brains where individual neurons were found, and part of their functioning was discovered to be based on relatively simple activations, combinations of activations, neurons coming together on other neurons and either inhibiting them or activating them. And this led to considering mathematically modeling what's going on here, and a discovery that, sure enough, if you have enough simple units like little neurons that don't do much except decide whether to go on or off, and you interconnect enough of them, you can actually do some serious processing. So some of the early work, for example, proved that networks of these very simple units could do things like symbolic logic. And today, I'm going to be talking a lot more about neural networks because they have been the driver in the last 6 or 8 years of some of the most impressive advances in AI. Today, they're used, for example, for facial recognition. You know, I look at my iPhone and it looks at my face and unlocks, that sort of thing. Another form of AI is, I'm calling it symbolic logic, which is kind of an oversimplification, but the idea there is that it's based on representations that humans come up with. So for example, Google Maps, the AI that helps us find our way, finds the quickest route, is based on a representation of the world, maps, digital maps, and some algorithms that have been developed to do efficient searches for best routes, that sort of thing. So this is quite different than neural networks, for example, because it really relies on a human developed framework and some rules that humans figure out to be able to navigate through that framework and figure some things out. A third kind is expert systems. And this is a kind of AI that relies on a knowledge base. One version of that is, one of the early versions were trying to put medical information in a knowledge base that could be accessed by someone with less knowledge than the expert in order to help make decisions. Today, these sort of things are used for chatbots. For example, automated systems that can field calls from customers, even field complaints, and so forth. And so this relies although some component of it, some parts of it may rely on understanding, decoding human speech. The primary thing here is to be able to, okay, they're referring to this particular item, to this particular product, and being able to effectively look up the information that's needed about that, and beyond that, to be able to do some reasoning and logic to be able to come up with a reasonable answer. The IBM Watson that did so well in Jeopardy used very much this sort of activity that relies on humans developing a knowledge base that can then be used by the AI. There's an interesting project called Psych that was started in the 80s and is still going, based on the notion that if we could only stuff enough information into a computer, it could become really intelligent. And they're still at it, and it's still not really intelligent yet. But this is an important aspect. And then finally, we engineers and mathematically oriented people like this approach are AIs that are based on mathematical statistics. And the foundations of this go way back. Although AIs itself really started in the 50s, it's been going on for quite a while. Mathematical statistics is even older, and it's still used today for things like AIs that are used to analyze the stock market, recommendation machines, so that when you're on the web clicking on things, ads are targeted to you based on probabilities of your buying particular items. And so AIs use all these things today, and very often systems that are useful to us, that are engineered to us, use multiple aspects of this. In the history of AI, it's kind of interesting how sort of started out with neural networks, and then pretty soon people were all excited about it. I remember seeing headlines back in the 60s, US Naval Research coming up with artificial brain. You know, how long is it going to be before effective machine translation will be available by 1960? And it ended up being far less effective back then than expected. And in fact, so much so that by the time the 70s rolled along, there was so much disenchantment with neural networks particularly, it created something that practitioners in the field call the AI winter. And this was when people were so fed up with the overpromises of AI that funders like the Advanced Research Projects Agency just stopped funding it. They just didn't believe it anymore. Fortunately, there were a few holdouts that always thought, and new people come along and they don't realize that this has already been disproven to be effective. So they say, oh, this is really cool. You can have these machines that you can put together simple elements, and they're kind of like the brain, and you can train them and so forth. And they kept at it, and it's a really good thing, because some of the most important breakthroughs in the last few years have been actually made by neural networks that I'll talk about. But for a long time, neural networks were out of favor. Symbolic logic was going to do it. We had back in the 80s, the Japanese fifth generation computer experiment. Everybody was worried. Japan was a strong economy, and the fifth generation creating very fast expert systems that were populated by huge amounts of data were going to be intelligence systems nobody has ever seen before, and Japan was going to take over the world. People were so worried about what they were doing that, Europe and the US so I guess we got to create, competing programs for these things. So eventually it's come to be passed that, as I said, all these things have come in and out of favor during the history of AI, but they're all used to some extent now for practical systems.
We have a question on the floor.
Yes,
which
sure.
is, how is AI related to the bot's capability to learn?
I'm going to be talking about learning. Yeah, how there's a very specific way that most of the machine learning is done today. So I'll take that question in a few minutes.
Okay, great, thanks.
All right, so one of the things I mentioned is that neural networks fell out of favor, but now they're very much in favor. And it's a version of neural networks called deep neural networks. And it's based on the picture I showed you before. Basically, it's inspired by brains, by biological brains. Only back in the old days, you would have maybe 10, 20 of these units working together, and you can do some pretty impressive things. But deep neural networks have many, many more, and I'll be talking specifically about how many they have. But the idea is that with these interconnections of artificial neurons, they're called, they do relatively simple things, but there are so many of them that they can do some pretty fantastic things. And basically what all these machines do, what all these AIs do, is they take in data in some form. It could be a speech waveform, it could be a picture, photograph, it could be some information from sensors coming out, and they recognize patterns in the data. And that's what these deep neural networks do, and that's what the most advanced AIs today, basically what they do. So why is that a big deal? You know, something that can recognize patterns. Well, let me talk about patterns. I mean, patterns is a commonly used word, you know, often used as talking about, you know, pattern to create a component of a wood project or a clothing or so forth. But patterns in the sense of the kind of pattern recognition that AIs do is a very broad term. And patterns are actually pervasive in our lives. So even early life, nature, there are patterns in nature that are very important. Patterns in the sky that inform us about weather and inform human events. Patterns in nature, like the zebra pattern, that's part of its survival mechanism in confusing lions, tigers, other predators that come after herds of zebras. Humans have used patterns, learned to track animals, to avoid poison mushrooms. All these things involve patterns. In a more modern setting, as we drive along in the car, we're presented continuously with patterns that we react to, and that's what driving is. Social patterns are extremely important to human beings. The way we recognize our mothers, the way we recognize friends versus foes, the recognition of nonverbal communication. These are all hugely important patterns in human life. Then there are some other kinds of patterns that are a little bit more removed. So for ages, people have noticed the stars, and they've superimposed patterns that we as humans imagine on them, like the Orion, you know, the hunter in the sky. And an even more removed, abstracted from nature version is celestial mechanics, which is based on patterns created by human beings intended to represent part of nature and to allow us to understand nature better, predict eclipses and so forth. Another important kind of patterns in our lives are structured ways we communicate with each other in books, musical scores, communications such as Morse code, and also schematics that help us communicate designs and guide construction. We use patterns, we invent patterns that help us make decisions, like trying to judge the stock market, do good investments, solve a homicide case. You know, you've probably all seen these detective shows where they're trying to put together all the evidence and come up with what's going on here, these murder boards. And then, of course, we're so smitten with patterns, we amuse ourselves with them. Games such as chess. Chess masters are masters at judging the pattern on the board in order to strategize for the next move. So that's what's so pervasive and useful about machines that can recognize patterns, because they're all over the place and there's a lot of applications to them. The other thing I mentioned that's significant about neural networks is that they use data, and there's two ways in which that's significant. One of the main important ways these days is that we're flooded with data, digital data. This is just one particular piece. It's no surprise to any of you. Gigabits of data are used by each of us every day. A terabyte, which is 1,000 gigabytes, a petabyte, which is 1 billion bytes. There's data all over the place. And that has two particular implications in AI. The availability of so much data has really enabled artificial neural networks, which previously were hampered by slow computers and not very much training data. Now we have very much faster computers and as much data as we need. And this has enabled things to be done with artificial neural networks, with deep neural networks that were never anticipated before. And the second significance of this, not just enabling these training these smart networks, which I'm going to talk about a little more detail, is that so much of life now is revealed in the digital streams around us. So that means that a machine that can access the internet, can see, can hear, can take in a very much more of life than prior eras.
Tom, if I could jump, I have a question. This is David.
Yes.
I mean, it's also reasonable to say that so much of that there are huge amounts of data that are actually not being captured as well. Is that fair to say? Like, for example, things that aren't necessarily quantifiable, but are, you know, are effectively data. They're information, like people's emotional states, or how people are, you know, if people are feeling lonely or isolated. And does that somehow, you know, kind of like if you're slowly getting off on the wrong track, is it not unreasonable to think that 10 years later we're going to be way off track?
Yeah, well, what you're pointing out is one of the things that separates natural and human intelligence.
Yeah.
Artificial intelligence is not good at empathy at all. Researchers try to imitate it with bots with faces that depict emotions. And, you know, I think this is just one of the many areas that separate artificial and human intelligence. And you wouldn't know there's much separation sometimes reading some of the news. There are, it's interesting that even experts in the field write books that seem to imply that, you know, we're going at such a rapid pace, we just need to do more of the same in AI, and pretty soon they'll take over the world.
And our problems will be solved.
Yes. Yeah. Yeah. No problem is fundamentally, and that's, I think that's a vast oversimplification and just wrong.
Yeah. Okay.
Tom, a couple things. Dan had a question kind of going back to the winter end. And did that end just because of competition, or was it due to increased computing power?
The early neural networks were hampered because what we've discovered now is that they really don't get into their own until you have a million times more data to train them with and a million times faster computers. And now we have them. So back then, they were able to do some interesting parlor tricks, and it made people so excited over promises happened. But the winter happened when the expectation, the capabilities of early neural networks sort of ran into a wall because of limitations. There's also a second thing that was very significant, and that is one of the leaders in the field, Marvin Minsky, and his colleague Seymour Papert wrote a book called Perceptrons, which Perceptron is a name for an early version of neural networks that prove mathematically the limitations that fundamentally the simple neural networks of the day were very limited. And that was an extremely influential book, and said, well, I guess now we got the theoretical proof that they're limited. So those two things were the most significant causes of the winter.
Okay, great. And I just wanted to point out one thing to everybody. Tim has pushed a really interesting link from Time Magazine about some learnings around our great upheaval in this present time and how it was actually determined based on data.
Yeah, thanks. Okay, so I want to make some of these ideas a little more tangible. And so today I'm going to introduce you to two AIs. And the first one is a really simple AI. His name is Coltron. He's a robot that learns to predict ice. And I mentioned that one of the really important things and significant things, and for some people scary things about modern AI, is that they learn. And the sense, a machine that can learn, what's to prevent it from learning how to re-engineer itself and learning how to be an AI engineer and suddenly start creating AIs that are smarter than the ones humans can create and so forth. What's to prevent that? Well, one thing that helps put that in perspective is, how do these machines really learn? So that's what I'm going to talk about here. So I'm going to show you how we're going to design a robot that learns to predict ice. And so, very simple robot. So basically, Coltron, you tell Coltron the temperature in degrees Fahrenheit, and Coltron says either it's freezing out or it's not. And since Coltron is a robot, he speaks in robot language. And so 1 means freezing and 0 means not, okay? So this is Coltron. As engineers, we're going to design Coltron with a 1-parameter neural network. What do I mean by that? Well, in this case, it's going to be a very simple neural network that has, and I'm sorry, I'm going to get a little math engineering on you here, but bear with me. I think, I hope you find it interesting. So the idea is that Coltron's going to have this single artificial neural network, and it does a very simple thing. It takes whatever the temperature number is for degrees Fahrenheit, and it adds to it this thing called P. And this is the thing I'm calling a parameter. And the significance of parameters in a neural network, even in complicated ones, is these are things that are adjusted. And the adjustment of those parameters is what constitutes learning in a neural network. And so the idea is that this simple neural network is going to add whatever the temperature is to P, so you get out F plus P. And then there's this other thing that looks a little more complicated, but also actually what it is a thing that says, I'm going to send out a 1 if whatever the result of F plus P is negative, and I'm going to send out a 0 otherwise. That's all this means. And so my conjecture as an engineer is that this sort of structure will be able to do the job, but there's this one thing here, parameter P, that I have to figure out. And so my hypothesis as an engineer is that if I find the right value of P, Coltron's going to work the way I want him to work. And so, okay, well, let's just sort of play around with it and say, let's guess at a value of P. Let's say P equals 7. All right, let's try it out. Let's say the temperature is 65, P is 7. If you add those two together, you get 72. It's positive. Therefore, you put out a 0, not freezing, because it outputs, if it's above 0, then you put out a 0, and not freezing, which is the right answer. Hey, that makes 7 look like it could probably work. Well, let's try another example. How about 28? So we're still guessing that P equals 7. We add 7, 28, and we get 35. We put it through this thing. And since this is positive, it outputs a 0, which is not freezing. Well, that's wrong. So obviously, P is not a good example. So basically, the way that these machines learn, even the complicated ones, is through a process called training, where examples similar to the one that I just gave you are presented. You start out maybe with just a parameter or a set of parameters that are just random. And if the answer that you get is the one that you want, you sort of have to know what's free in order to train it. The teacher has to know what the right answer is. If Coltron gives the right answer, you say, okay, I'm going to keep that value of P. If Coltron gives the wrong answer, then you're going to adjust the value of P. And some of the most important research that's really enabled current complicated networks is that engineers have figured out techniques for adjusting P using training samples. So I'm going to give you a really quick example here. So I'm going to present in the next couple of slides here a bunch of examples. We're starting out here with a value of a guess of 7. And okay, 50, good answer. 20, wrong. So I'm going to adjust. In this case, I'm going to change 7 to -20. Let's try it again. Okay, put in 0, right answer. Put in 27, wrong. So now I'm going to adjust the parameter again to -27. 14, I put in 14, it should give a 1. Yeah, it's right. 66, still right. 2, that looks right. -4, still giving the right answer. 72, still the right answer. 30, wrong answer. I got to adjust P again to -30. 11, still right, still right. Oops, got a wrong answer at 32. The adjustment technique I'm using puts it down to -32. And those of you who may have guessed that -32 is a good answer, and in fact, it's going to give us the answer all the time. So this is basically what machine learning is. It requires engineers to set it up. It requires adjustable parameters. It requires an algorithm to adjust. And so this turns out to be very powerful, but it's very simple also. So quickly, I want to talk about how big are these networks here. All right, here's, to me, it's mind-boggling. This is a particular AI that was developed 6 years ago now. What it does is it takes speech, waveforms in, and it produces text out. It's a very complicated AI. As you can sort of see in this diagram, there are boxes there. The boxes represent complicated networks on their own. This particular AI has 5 billion connections. And it's trained using, 3 million audio samples. and 220 million text samples using a 495,000 word vocabulary. And it got very good. So big numbers. We're going to play with the second AI very quickly here. This is an AI called MobileNet. It's a very complicated AI, but it's not as complicated as the one I just showed you. This one only has about 4 million connections. MobileNet has been developed specifically to be used on mobile devices. And in fact, a version of MobileNet actually operates on iPhones. And so what we're going to do is we're going to use MobileNet, a version of MobileNet, to run an experiment here. So let me stop sharing, and we're going to do something else here. All right, let's share a different screen. All right, can all you see that? Okay, so this is, MobileNet is underneath this great interface, compliments of Google. And what I'm going to do is I'm going to train MobileNet to recognize the difference between me and David, my colleague here, that's our co-host here. And so it's going to be a very simple experiment. I just have a few pictures of me and a few pictures of David. And we're going to present it to this model, and we're going to train the model to recognize the difference between David and me. So again, very, very few examples. And you can see that right now it's being taking input from a webcam. It's been trained to recognize the difference between David and I. It's looking at me right now, and it's doing, depending on where I am, it's doing a pretty good job. Usually, let's see if I get closer. See, the pictures were taken, pretty much full on. And so when I'm that close, it does a pretty good job of recognizing me. One of the interesting limitations of these neural networks is that they're only as good as the data they're trained on. So while this neural network now has gotten pretty good at recognizing the difference between David and me, let's throw it something that it's not seen before. Like this, for example. Oh.
Well, that looks like me.
Yeah. Actually, the first time I did it, it thought it was me. Yeah, it's pretty sure it's David.
And Tom, it's only comparing to the photos of me, correct? Not to the camera of me right now.
Correct, correct. Here's another. It's pretty sure that one's me. I think it's the shiny head. So this is just a particular very simple example, but I wanted to make 2 points with it. One is that there's a very powerful neural network that's been developed, and believe, when you give it the right number of training samples and so forth, it's right there available. And the second thing is that even if you've been trained on 10,000 pictures of no, more like 1 million pictures of 10,000 different objects. If you throw it something that it hasn't seen before, who knows? It'll very confidently predict the wrong thing. So that's one of the limitations here. Another point I want to make is that I want to make a comparison. Now going back to the speech to text translation thing, the 5 billion connection, very complicated text. It's it's very effective as an engineered device to do a useful task. However, it's quite different than what humans do. So let's consider what humans do when they translate, listen to language and translate it. There's a auditory lobe in the cortex that receives and digests the sounds. There's an area where syllables and words are formed and understood, and then they can be translated into memory or into some kind of response. Huge difference here. The human, it's not just sounds and words, it's reference to the real world and relationships. Like if you're talking about families or brothers and sisters, those things are inherent in the human's understanding of language. This AI has no concept of that. It simply has established a correlation between speech waveforms and text without any understanding of the meaning of the text.
Including, if I can add it, Tom, as a question, including some of the cultural differentiations that might exist in how we interpret the same words, for example.
Yes, yes. The only way that it would get a handle on that is if it had in the examples some of those cultural differences.
Mm-hmm.
Yeah.
Or even tone of voice. Same word means something totally different if it's said sarcastically.
Mm-hmm.
Yeah, yeah. Oh, by the way, yeah. The human brain, I mentioned that the human brain was inspiration for artificial neural networks. And in fact, there are some similarities, but there's far more that's not known about human brain's work, and it's far more complicated than neurons that fire on and off. And so, for example, this is one indication that the amount of brain material involved in this human processing is 5,000 billion connections. So 1,000 more connections in just this one particular area. The last point before we get into more specific discussion of organizations is one of the things that really surprised me is how accessible AI technology is. This is a picture of an event sponsored by Amazon Web Services, where Amazon encourages learning how to use the AI technology that's hosted on their cloud. And you can go to, and this is true of Google, and it's also true of Apple. They make it extremely easy for anyone who is interested to learn how to use their technology. Go as deep as you want. You can program AIs for your business without even knowing basic AI programming languages like TensorFlow or Python and so forth. If you want to learn those things, if you want to create apps that use AI on your iPhone, you can go to an Apple website. This is all free. You can learn their language that they use on their iPhones. It's called Swift. You can actually play on something called a Swift Playground that will teach anyone. It could be an interested high school student the fundamentals of programming and how to use this particular language. And then you're off and running. And the other thing is that over the last few years, these very complex AIs have been developed to recognize pictures, sounds, that's language, that sort of thing. These are almost all open source, which means they are freely available to anyone who wants to use them. And you just have to learn enough to be able to use it. So far cry from the early days of computer science when everything was proprietary. So one of the helpful things for this transition is that it's easier than ever for people with the interest to be able to get into this field and make contributions. All right, so some takeaways here. AIs can do some amazing things. It requires extensive human engineering to bring them to the point where they can learn to do things. And what they learn is very specific to what they've been taught. There have been some amazing breakthroughs recently that have been enabled by these huge neural networks made possible by Moore's law, as somebody pointed out, using lots of data to learn to recognize patterns. And while neural networks borrow tricks from nature, humans' brains are far more complex and adaptable than AI. Just one example. How many times does a human baby need to hear a particular word before they understand it? A lot less than a few million, you know, which is what AIs take. Okay. And advanced AI technologies, surprisingly. So what I want to do next is let's talk more about the AI and organization development. And the key questions I want to ask and I want us to discuss are, what are the top challenges faced by organizations and employees in the age of AI? How will organization development, human resources, training and development need to respond to these challenges? To what extent can we rely on traditional roles and tools? And what things will need to change? So we're going to go off into breakout groups for a few minutes. And I just want to fuel that by this particular chart. It's an interesting chart. It's a little, it's got a lot of information. So first look at the circles. The size of the circles represents the number of US workers that are going to be displaced by automation in the next, by 2030. The color of the circles represents the college degree situation of those professions. So if it's black or dark blue, that means by far the majority of people in that work category do not have college degrees. And then the position of the circle on this chart, it's high vertically if a high percentage of the workers in that category will be displaced. And it's far to the right if the share of jobs in the workplace is high. So for example, what this shows us is that office support workers are both, a lot of them are going to be displaced, a high percentage of them are going to be displaced, and a lot of them don't have college degrees, which gets to a problem brought up earlier, like, okay, now these people are really going to be into trouble. All right, so I'm going to skip this, and I'd like to go to the breakout discussion now. And for about 10 minutes, I would like you and your group to discuss these questions, and we'll post the questions so that you can see them. We're really out of time right now, and what I'd like to do in the end is just, if a representative from each of our groups could give one word that would summarize implications of AI.
Well, I'm inclined to kind of counter offer. Can we have 3 words?
All right.
All right, I'll do one for our group, and then we still have credit for 2. So one word was interfaces. New.
Ah, okay.
One word for our group was transitions.
Another
group?
word would be pushback,
Pushback.
resistance.
Okay, go ahead, Jen.
Oh, fear.
Fear. Okay.
And Jen, and I would say from our group too, would be questioning.
Okay, well, thank you very much, all of you. I hope I've given at least food for thought. There's a lot of issues out there. I honestly believe that OD and related professions are going to be some of the most significant players in this transition. Adaptation to new technology has been part of what we do as professionals since forever, right? Arguably, some of the fields such as change management that's what the genesis of it was. So I think the big difference with AI is it's bigger and faster and probably more pervasive. So we got to recruit and excel at what we're doing. So thank you very much. I really appreciate your attention.